All right, guys, so you are on semester exam review, part B. So if you will, please. Hey. All right, so pull out your review. We're going to turn to where we left off last time. So we finished off at 35. You'll notice the numbers kind of skip around a little bit, mainly because last year I just feel like we had more time, so we had a lot more questions. And when I cut them, I didn't necessarily renumber everything, just because of time and stuff like that. So I don't know if you noticed, but yo girl got her nails did. So, all right, here we go. So number 37. This is a little bit tricky. It says we have a horizontal asymptote at 5 and a vertical asymptote at -2. So what does A plus C have to be? So here's what I would think about. First of all, a horizontal asymptote is a bobo, a botan, or a bed C. Okay, but if it was a bobo, it would have been y equals 0. If it was a botan, it would have been I don't have one. So if it's a 5, that means that the numbers in the front of these x's have to divide to 5, which pretty much tells me that my A has to be a 5. Does that make sense? So like if I have y equals 5x over x, that's going to give me this y equals 5 here. So I pretty much know that my A has to be a 5, okay? Now, B is a little bit of a mystery. Okay, but my vertical asymptote, that comes from a term on the bottom. So if it's at x equals -2, then I know this has to be a +2. So think about it. If I put x plus 2 on the bottom, if I plug a -2 into that, then I'm going to have a 0, which is going to make it cancel, right? So if I pick my A to be a 5 and my C to be a 2, then I'm going to have this horizontal asymptote, that vertical asymptote. So that pretty much means my A is 5, my B is 2, then A plus C would be 7. Okay, there is one very similar to that on your exam, so just kind of think about it. Horizontal asymptotes are the numbers in the front, okay, and then vertical asymptotes are numbers on the bottom. Now, number 38 asks you about discontinuities. Okay, so think about it. A discontinuity is anything that makes the denominator 0. Does not matter if it's a removable, like a hole that cancels out, or if it's a vertical asymptote. Those both count, okay? So let's put here, removable, the factor cancels, or a non-removable, the factor does not cancel. Okay, but either way, still discontinuous, because as I'm drawing it, I'd have to pick up my pencil to do a hole, or I'd have to pick up my pencil to do an asymptote. So from the top here, I can take a 2 out. So that's going to leave me with an x minus 1. Okay, then from the bottom, I need numbers that multiply to -4 and then add to 3. So I could do x plus 4 and x minus 1. Then from there, you're going to realize that your x minus 1's cancel out. That tells you that there was a hole or a removable asymptote at x equals 1, okay? So there's going to be a hole in the graph at x equals 1, and then the term that doesn't cancel creates a vertical asymptote. So I'm going to have a vertical asymptote or a non-removable or infinite discontinuity at x equals -4, okay? So you should know how to find both of those two things. All right, so we're kind of getting into derivatives from here. So let's say that we're doing number 41. Okay, so 41 says determine the equation of the line tangent to this function and parallel to this function. Okay, so the first thing you should think about is that parallel means that you need the same slope. Okay, and if my slopes are the same, my equations have to be equal. So what I'm going to do is I'm going to take the derivative of f the derivative of the line, and then I'm going to set them equal to each other. So f prime of x is going to be 2x minus 2, because it's just a simple polynomial there. Then the derivative of the line, y prime, is going to be -1. And then remember, if I want them to be parallel, I need them to have the same slope. So I'm going to set those equal. So I would let 2x minus 2 equal -1. Well, then I can add this 2 across. That gives me 2x equals +1, which means that x equals 1/2. Now, that's only the x value. If I want the full equation of the tangent line, I don't just need a point. I need a point and a slope. So for my point, it's going to be 1/2. And then for my slope, remember, I already know my slope. The slope of this line is -1. I want them to be parallel, then I need the same slope for my other graph, so that will be -1 as well. To find the y value, this is the same with implicit differentiation. Okay, you have to go back to the original equation, not the derivative, to get the rest of the ordered pair. Okay, so if I know that my x is 1/2 and I want my y, I'm coming back to this equation right here, and I'm going to plug that 1/2 in. So I'd have 1/2 squared minus 2 times 1/2. Sorry, I kind of ran out of room here. 1/2 squared is going to be 1/4. And then 2 times 2 is going to cancel with 1 on top, 1 on bottom. So that's a -1. And then rather than putting -1, I'm going to put 4 out of 4. Okay, and the reason why is because then I have a unit fraction, I have the same denominator, I can go ahead and subtract those. So 1/4 minus 1, or minus 4/4, would be -3/4. And then that would be my y value. And then those are the ingredients you need to write the equation of the tangent line, right? So let me switch colors here. Remember, the equation of a tangent line is y minus y1 equals mx minus x1. So I would have y minus -3/4 would be a +3/4. My slope is a -1, and then x minus 1/2. Okay, and that would be your answer. Now I do want to point out, when you do number 39, your answer is going to start off just like this. Okay, this is called point slope form. If I was doing 39, I would have had to basically solve it to put it in one of these forms. Okay, so remember, the only difference is you're always going to start here, but then you would just basically have to like distribute it and solve it the rest of the way to make it match one of those. Okay, so when you get to 39, you're going to still do all the same steps, put it in point slope, but then solve it for, this is called slope intercept form. But you'll still start basically in the same spot. Okay? All right, let's do number 42. So it says, find the values of x where the graphs are parallel. So your first equation is, actually, you know what? We have not covered this just because of the way that like COVID stuff has happened, and block schedule. So let's remove this little inverse symbol, and let's just make it to where f of x is tan of 2x. Okay, so the problem is that normally we would be a little bit further ahead. We would have covered inverse trig derivatives, but we haven't gotten there, which is totally fine. We'll get there before the AP test. So if f is tan 2x, okay, then f prime, which is the derivative of that, would have been secant squared 2x times 2. Now, think about that for a second. Okay, the rule that I use there is chain rule, because my tan, remember I eliminated the little -1 off of there. Okay, my tan had a 2x inside it. So I take the derivative of tan, I get secant squared, and then I multiply by an extra derivative of 2x, which is a times 2. Second function is y equals e to the 3x. Okay, and then just like the question I just did, if I want them to be parallel, Parallel means that I need to have the same slope, and the same slope means that I need to set the derivatives equal. So derivatives are equal. Now, you'll notice you have a little asterisk here. That means we're going to get to do the actual solving part in the calculator, but the derivative you still need to be able to do by yourself. So y prime equals, the derivative of e to the 3x is going to be e to the 3x times 3. And then you can put the 3 in the back like I did there, or you can put it in the front, doesn't matter. Okay? So what I'm going to do from here is if I need these to be equal, very important for the AP test, I need to show that I'm setting them equal. Okay, so 2 secant squared 2x equals 3e to the 3x. Okay, but then I'll solve in the calculator, but I still need to set up on my paper that I'm letting those two things be equal to each other. So here we go. I'm going to type in the 3e to the x is my y1. And it was e to the 3x. Okay, then for my y2, I'm going to do 2. Now, secant is 1 over cosine, so I'm going to actually end up opening up a fraction here. And then I'm going to do, 1 over, and then I want cosine of 2x, and then I want that squared. So just kind of take a second, look at how that looks. So it's 2 over secant 2x. So I have 2 over cosine 2x squared, which is the same as 2 secant squared 2x. Okay? And then from there, if I want to know where those are equal, I'm just going to graph and then look for where they intersect each other. So second trace. Option 5 is intersect. And then I did kind of change these without really checking it ahead of time. So let's see if they cross. It looks like they will. Okay, so it looks like they cross right in here. Okay, so first curve, I'm gonna push enter. Second curve, push enter. Guess, don't care about that. So it looks like they cross at negative 0.1167. Negative 0.1167. Now, keep in mind, okay, that because it said just to find the value of x, that's why this answer is good enough. If it had said find the point like it does in number 40 or find the equation of the tangent line, then I would have more work to do. But since this question only asks for the value of x, we're good. We're good to go on that. Okay? All right, I'll give you a sec to look at that. Then we're going to turn the page and keep on going. All right. All right, so number 44 says find the equation of the tangent line to the equation y equals 2x minus 3 over 5x minus 2 at the point where x is 1. So remember that in order for you to write an equation of a tangent line, you need two things. You need the point, and then also you're going to need the slope. Now, the point you're just plugging into the original function. So if my x is a 1, I'm going to just take 1, plug it in right here. So I'm going to put f of 1 equals 2 times 1 minus 3 over 5 times 1 minus 2. Okay? So then 2 minus 3 on top is a negative 1. 5 minus 2 on bottom is a 3. So then that's going to be negative a third. So I have my point. Now I need my slope, which is going to require me to take a derivative. And remember, if you're taking the derivative of a fraction, you're going to need to do quotient rule. Okay? So my high is going to be, I'm going to write it kind of like up here in the corner. Okay, my high is going to be 2x minus 3, which makes my d high just a 2, because I'm just taking the derivative of that. Then the ho is going to be 5x minus 2. which means that d ho is just the derivative of that. 5x minus 2 derivative is just a 5. So when I take the derivative, remember, it's ho d high minus high d ho. So dy dx equals, you could also call this y prime, f prime of x. It doesn't really matter, okay, as long as you label it with something. So it's ho d high, so that's 5x minus 2 times 2, minus high d ho is 2x minus 3 times 5. And then all of that over ho squared, which is 5x minus 2. Now notice that your equation only has x's in it. So that means I really only need the x value for me to plug that point in. So my dy dx at this ordered pair, which is 1 negative a third, is going to be 5 times 1 minus 2. So 5 times 1 is 5, minus 2 is 3. And then plug in your 1 here. 2 times 1 is 2, minus 3 is negative 1. Multiply that by 5, that's a negative 5. But if I minus a negative 5, we know that's going to turn into a plus. So on top, 3 times 2 is 6, plus 5 is 11. Bottom, we're putting a 1 right here. So 5 times 1 is 5, minus 2 is 3, 3 squared is 9. So your slope is 11 over 9. And then from there, you would just write the equation of your ordered pair, or of your tangent line. So my slope is 11 over 9. So 6 minus 6 is 11. Okay, yeah, that looks good. And then from there, you would do y plus a third, 11 over 9, x minus 1. Okay, but remember, the equation of a tangent line needs two things. It needs a point and a slope. So the point you plug back into the original, slope you plug into the derivative. Okay. All right, let's see. Rest of this page, I feel like you need to know what rule to use, but for the most part, none of them are really hard except for maybe 47. So 47, your equation, it's f of x, so let me rewrite this. H of x equals f of x times, and then 4g of x minus 2. Okay, so the notation on this one is a little odd, but it's basically asking you to find h prime. So you just have to kind of pick what rule you're going to use. So I can see that the first part of my function is f of x multiplied by 4g of x minus 2. Okay, so when I notice that that's a multiplication of two functions, I know I'm going to have to use product rule. So my u is going to be f of x, and my v is going to be 4g of x minus 2. So if my u is f of x, my u prime is going to be f prime of x. Okay, because I'm just taking the derivative there. And then if this is 4g of x minus 2, derivative, that would be 4g prime of x. 2 is a constant, derivative of a constant is 0. So that means that my h prime of x is going to equal this diagonal plus that diagonal. So it's going to be f of x times 4g prime of x plus, product rule is plus in the middle. And then your other diagonal is f prime of x times 4g of x minus 2. Okay, what I just wrote is wrong. Think about why. We've talked about this a couple times before. It's very subtle. Okay, but if any of your terms has addition or subtraction, these parentheses are necessary. Okay, otherwise it is wrong. You're going to lose points on the AP test. And if you typed it into a calculator, it would give you the wrong answer as well. Okay, so that 4g of x minus 2 has to be grouped together, okay, because that's what's correct. So from there, we're wanting h prime of 3. And then we have all these kind of different little values here that they gave us for us to plug in for 3. So I'm ready for h prime of 3. So f of 3, it tells me is 2 times 4 g prime of 3. G prime of 3 is 5. F prime of 3 is -1. 4 g of 3, that's a regular g, not a g prime, so g is 0, minus 2. So 4 times 5 is 20, times it by 2, that's going to be a 40. Then 0 minus 2 is just a -2, times a -1 is going to be a +2. Okay, now notice that one only asks me for h prime of 3. So I'm not trying to write the whole equation, the tangent line, unless I have to. Okay. All right, so peek ahead. What rules do you need for 51, 53, and 56? Okay, your choices are product, quotient, or chain rule. Okay, so I'll give you a sec to think about it. Chain rule is a function inside a function. Product rule is when functions are multiplied together. Quotient rule is when they're divided. Okay, so 51 is a chain rule. Okay, your middle function is here, raised to the power of 3/4. 53 is a product rule because you have this times this. And then 56 is, think about it. Okay, that's the sine of 2x. And then all of that raised to the power of 4. Okay, so think about that's actually a double chain rule because you have 3 layers. Your inner layer is the sine 2x, or I'm sorry, the inner layer is just the 2x. That's plugged into sine. And then all of that is plugged into the 4th power on the outside. Okay, so just kind of keep in mind, you have all these different rules you got to keep track of. Let's go ahead and do 56. So if that's f of x, f prime of x, remember I have to start on the outside. So my 4 is going to come down to the front. And then my sine of 2x stays exactly the same, but I power it down. And then I multiply by its derivative. Derivative of sine 2x is cosine 2x. Keep the 2x exactly the same, but then multiply by its derivative. So the derivative of 2x is an extra times 2. And then in my last step, before I plug in my number, I can combine the 4 and the 2 to be an 8 cosine of 2x multiplied by a sine of 2x quantity cubed. Now that's the derivative for whatever x I want. Specifically, I want pi 6. So when I plug in my pi 6, I'm going to plug it in here, and I'm going to plug it in here. So f prime of pi 6 is going to equal 8 times the cosine of 2 pi 6, and then the sine of 2 pi 6 quantity cubed. And then you should realize that pi 6 is already a reference angle, but when I multiply with that 2, that's actually going to turn into a pi thirds. Okay, which is a completely different reference angle, both if you do hand trig or if you do unit circle. So 0, pi 6, pi fourths, pi thirds is here. I want cosine first. Cosine is my top finger, which is a half. So I'm going to have 8 times a half multiplied by, come back to your pi thirds, which is here. Sine is going to be cubed, but I can see I have 3 fingers. So that's going to be root 3 over 2. And then that's going to be, oops, cubed. Okay, then the last thing probably you're going to notice is that if you were to multiply this out, okay, across the bottom, 2, when you cube it, okay, 2 cubed is 8. You would have an 8 in the denominator. Also this 8 in the numerator. Those guys can totally cross out. And so your final answer would be that you're going to have a root 3 cubed on the top and then just an extra 2 on the bottom. Okie dokie. All right, let's turn the page, please. Trying not to go too fast. It's weird, like, since I don't have y'all here, like I'm just kind of, you know, doing whatever. Don't have anyone to be like, wait, Miss Joyner, you know. All right, so implicit, I'd like to do, let's skip ahead to number 60, please. Okay, number 60, so we have 1 minus 6xy equals 17. It says, written in terms of x and y, find dy dx. Okay, so first thing that I noticed right off the bat, okay, is that out of that equation, one of those terms is going to need product rule. Specifically, it's this one. Okay, and you need to include the negative in the product rule. So my u is going to be the negative 6x. My v is going to be the y. So my u prime is going to be negative 6. My v prime is going to be dy dx. Now remember, these aren't dt's where I'm looking for a t. As long as it's an x for a dy dx, that's good enough. I don't have to put anything on the end of any x terms. Okay, so here we go. The derivative of 1 is 0. The derivative of negative 6xy is going to be negative 6 dy dx minus 6y. And then the derivative of 17 over here, that's just going to be a 0, okay? Because remember, 17 is just a constant, derivative is nothing. Okay, I'm going to take my negative 6y, add that across. So I have negative 6x dy dx equals positive 6y. Then from there, divide by negative 6x on both sides. And now I know that my dy dx equals 6 and 6 can cross out, so that's just going to be y over negative x. And then remember, it doesn't really matter where you put the negative. I'm just going to kind of put it in the front. Okay, as long as you don't put it in both spots, it doesn't matter if it's top or bottom or in front. Okay, part A says, find the slope at the point where y is 1. Then use the equation, the tangent line of the curve to estimate 3.1. Okay, well, let's see what happens with that. So my y is 1. Remember, anytime that you're trying to complete the point, you need to go back to the original equation. So if I have 1 minus 6x times y, which is a 1, equals 17, I can minus that 1 across. 17 minus 1 is going to give me 16. And then divide by negative 6 on both sides. And I know that x is going to be 8 over 3 negative. So my ordered pair, my x is negative 8/3, comma 1. So I have the x, I have the y. That's really all that I needed at this point for me to go back and find the slope of my point. Okay, remember your notation. It's going to be dy dx at negative 8/3, comma 1. And then when I plug that in here, I have negative y, which is a 1, over x, which is a negative 8/3. Whenever you divide a number by a fraction, you're multiplying by the reciprocal. So that's going to be negative 1 multiplied by 3 over negative 8, which is going to be positive 3/8. Because I have a negative on top, negative on bottom, those cancel out. All right, so I have my point, I have my slope. Those are the ingredients you need for a tangent line. So for my tangent line, I'm going to do y minus 1. My slope is 3/8. And then my x is going to be negative 8/3. Oops, hold on. X plus 8/3. Okay, because remember, it's x minus x1. So if I have a negative 8/3, I'm going to make it x plus 8/3 in the equation. Okay. from there, we are trying to estimate the value at 3.1. So I'm going to take that value, 3.1, and I'm going to plug it in here. So remember what I told you. If it's an easy decimal, go ahead and switch it over. Okay, but if it's a fraction like 3/8, to me, I would probably just leave that alone. So I would have y minus 1 equals 3/8, 3.1 plus 8/3. And then the last thing that I would do is I would just add this one across. Okay, because I am not trying to mess with all of that. Okay, so when I plug in 3.1, I'm trying to add 8/3 to it, then times it by 3/8. Too much. I would say just add the one across and then that's good enough, especially if it's free response. Okay, it doesn't even matter. They're not going to grade if it's simplified or not, as long as it's not incorrect. All right, so we took our derivative, we found our point and then plugged that in to get our slope. We wrote our equation of our tangent line, then we plugged in the decimal they gave us. The next step that they're asking us to take is to find the second derivative. So if this is my first derivative, then the second derivative is going to require quotient rule, okay? So I might need a piece of scratch paper, but we'll try. We'll try to fit it on here. Okay, so the high is going to be negative y, which means that d high is going to be negative dy dx. Ho in the equation is the x, which means that d ho is going to be the derivative of x, which is 1. So if I'm looking for my second derivative, the derivative of dy dx is going to be d squared y dx squared. And then I'm going to do ho d high, so x negative dy dx, minus high d ho, which is negative y times 1, all divided by ho squared, which is x squared. And then actually, it looks like some stuff's going to cross out here. So I have minus and negative on the y's. Those can cancel out. Plus, plus. And then remember also that I have an equation for dy dx. Remember what we put up here. Dy dx is really just negative y over x. So if I come back over here, I'm going to have x times negative dy dx is going to be negative negative y over x, which is just going to go back to a positive, plus y over x squared. Think about that for a second. The negative in my dy dx is canceling out with this other negative. So they both had one, so they just kind of eliminate. Then from there, this x and that x, these guys are gone. So I just have y plus y. That's going to give me 2y. So then I have 2y over x squared, okay, which simplified quite a bit. Now remember that the second derivative has a very special job. Okay, the second derivative of an equation determines its concavity. So if I want to know the concavity at my point, I just have to go back and plug it in. So if I want dy dx squared squared at negative 8/3, 1, then that's going to mean I'm going to have 2 times y, which is 1, divided by x squared, which is negative 8/3 squared, which means on top I'm just going to have a 2, and then negative 8/3 when I square it is going to be 64 over 9. Okay, now we could get into like what the specific answer is. So I could multiply by the reciprocal of this, blah, blah, blah. However, all that they want to know is whether my answer in part B is an over or an underestimation, which means I really only care about concavity. If the second derivative comes out positive, which it did, because the negative on my negative 8/3 canceled out. Remember, we squared it, it's gone. So if this comes out positive, that tells me that my graph is concave up. And if my graph is concave up, that means that my tangent line is going to fall below the actual value. So I can automatically assume that my answer that I used in my tangent line, okay, this craziness right here, it has to come out to be an underestimation because my second derivative came out positive, and that determines the feature of my graph, concavity, is concave up. Okay, so let's try to squeeze that in here. Okay, so y is concave up. So tangent line is below actual value. Okay, now again, how do I know y is concave up? Because the second derivative came out positive, and that's the feature of the graph that the second derivative is in control of. Okay, first derivative controls slope, second derivative controls concavity. Okay, if my graph had come out to be concave down, if you can kind of picture what the graph of that would look like, a concave down graph, your tangent line is going to cut above it. So that should kind of make sense how you're picking which one is which. Okay. All right, how much do we have left here? Oh, all right. Let's, come on guys, let's rally. End of the quarter. Okay, you can do it. End of the semester. All right, we'll get through the derivative test, then we'll take a little break. All right. So I'm going to skip the latter question. We can come back to it next time, but we've done a ton of those. So let's jump ahead to number 66. So it says, find the absolute max on the interval from -2 to 3 for the function f of x equals this guy right here. Show the analysis that leads to your answer. So first thing that I would notice is that a max or a min is a first derivative test. So I'm going to take f prime of x. Derivative of that would be -6x squared. So -3 times 2, -6x squared plus 18x. Then I'm going to set that equal to 0. Take a -6x out of that. Have an x left over and then a -3. Notice since I'm taking out a -6, that's why my 18 turns negative. Which means that my critical numbers are going to be 0 because of the x on the outside and then 3. Now, if I wanted relative mins and maxes, I would go ahead and check like a first derivative test. But since I want absolute, you have to do a candidate's chart. Okay, and remember, a candidate's chart, you don't care if it's the winner in its own little area. You only care about if it's the winner everywhere. So I'm going to put -2 and 3 in my chart because those are my endpoints. And then I'm going to put 0 and 3 in my chart. But then I notice 3 obviously is a repeat. It's an endpoint and it's a critical number. When you plug into your chart, you are plugging back into the original right here. Okay, so let's do -2 first. So I'm going to have -2 times -2 cubed plus 9 times -2 squared. -2 cubed is -8. Multiply that by -2, that's a positive 16. -2 squared is a 4. 4 times 9 is 36. So that's going to be 6 and 6, that's 52. Okay, then we're plugging in 0, so I'd have -2 times 0 cubed plus 9 times 0 squared. 0, 0 gives me 0. Okay, let's go with 3. -2 times 3 cubed plus 9 times 3 squared. Well, 3 cubed is going to be 3 times 3 is 9, times 3 is 27, times it by -2, that's -54. 3 squared is another 9, times 9 is 81. And then if I do -54 plus 81, we're going to get 27. So then out of that chart, I could just kind of look at it and see what's the biggest Y value, what's the smallest Y value. Now, specifically, I guess, if I only really care about the absolute max, then I'm just looking for the biggest Y value, which is going to be 52. So you would say the absolute max is 52. It occurs at x equals -2. Okay. All right, go ahead and turn to the next page for me, please. Okay, next section, we're going to be continuing with derivative tests. Yeah, let's do number 68. Okay, so first thing we want is increasing and decreasing intervals. So both of those have to do with the first derivative test. Okay, the first derivative is going to tell me when my function is increasing and decreasing. So first thing I'm going to do is take f prime of x. So 3 times 2 is going to be 6x squared. 2 times 3 is going to be plus 6x. That's like an x to the 1. 1 times -12 is a minus 12. So I have 6x squared plus 6x minus 12. Then I set it equal to 0 because I'm looking for my critical numbers. I see I can pull a 6 out of there. So I have x squared plus 1x minus 2. So I need numbers that multiply to -2 and that add to 1. So I could do x plus 2 and x minus 1. Which means that my critical numbers, where I could have a min or a max, are going to occur. I'm going to put it up here at the top at -2 or +1. Okay? Then from there, let's pick a number bigger than 1. Say we pick 2. So 2 minus 1 is positive. 2 plus 2 is positive. Times it by 6, it's still positive. So that means that f would have been increasing because f prime came out positive. Okay, between -2 and 1, let's say we pick 0. 0 plus 2 is positive. 0 minus 1 is negative. Multiply positive and negative, get a negative, which means f would have been decreasing. Before -2, let's say we pick -3. Negative, negative, multiply 2 negatives, get a positive. Which means that I have a max at -2 and a min at 1. So my question specifically though is asking, where's my function increasing and decreasing? So I would say I'm increasing on the intervals from -∞ to -2 and then 1 to infinity. I'm decreasing on the interval from -2 to 1. Okay. Now, one other thing to point out here. Okay, the max and min that I just found are both relative or local maxes and mins. So in part B, when I'm looking for an absolute, that's when you have to switch to your candidates chart. Because you don't want to know, am I just the winner in my own little area? You want to know overall, is this max the biggest it gets? Is this min the lowest that it goes? So for absolute, you need to do a candidates chart. And remember that for a candidates chart, 2 things go in your chart. Your x's of your endpoints, which are -2 and 2. And then any critical numbers, which would be -2 again, and then 1. Plugging back into the original. So I'm going to use a calculator for this one because, you know, it's like 10 o'clock at night on a Friday. So I'm typing in my equation here. So it was 2x cubed plus 3x squared minus 12x. And then I'm going to go into my table, and I really only care about those 3 numbers. So at -2, my value is 20. At 1, my value is -7. And then at 2, my value is 4. So then if I want the absolute minimum, that means my absolute min is going to be -7. So absolute min is -7. It occurs at x equals 1. Okay. Now, part C asks me about concavity. So remember what we said, concavity is concavity has to do with the second derivative. So if I have f prime up here, that's not good enough. I need to get down to f double prime. So if that's f prime, f double prime is going to be 2 times 6 is 12x plus 6. And then -12 derivative, that would just be 0 because it's a constant. Then from there, set it equal to 0, take out a 6. You have a 2x plus 1, which means that your possible point of inflection, I don't know if you remember us calling it a PPOI, would be at x equals -1/2. Okay, but you're not sure that it's a point of inflection until you do the sign chart, which is like what we did right here for the first year. So, -1/2. I want smaller than -1/2. Let's say I pick -1. -1 times 2 is -2. -2 plus 1 stays negative. Times it by 6 also stays negative. Not a double root, so I know it switches to be positive. Then remember, when f double prime is positive, f is concave up. When f double prime is negative, f is concave down. So that means that my graph, let me switch colors here. Okay, I would be concave up on -1/2 to infinity. And then I would be concave down on -infinity to -1/2. Okay. All right, last question to do with that. It says, when is my function increasing at a decreasing rate? Okay, so if my function is increasing, let's break this down. Increasing means that f prime needs to be positive, but then at a decreasing rate means that f double prime needs to be negative. So they're giving me a very specific combination of signs that I need to check for as I'm working through my two derivative tests. So I need a positive first derivative, but a negative second derivative. You can redraw the line chart if you want to. I'm going to, but you probably don't need to. So if I go right here, let's just squeeze it in right here. So I had -2 and +1, and I went plus, minus, plus, and I had -1/2, and I had minus, plus. So specifically, I'm looking for a positive first derivative that happens here and here, but then I need a negative second derivative that only happens here. Then the interval that I have both of those would be where those overlap, which would be from -infinity until -2. Okay, so right here. So that would be from -infinity till -2. That's for part D. Okay. All right. All right, last one we're doing for today, go down to number 71. So 70 and 71 are very similar, different words, but mostly the same question, or at least the same concept, we'll say. So it says, let G be a twice differentiable function with G prime greater than 0, G double prime less than 0, such that G of 4 is 12. So let's make a little chart here. So at 4, my x is, or when x is 4, y is 12. And then when G of 5 is 18 means that when x is 5, G is 18, which is a possible value for G of 6. So basically, I'm trying to pick what could go in that spot. Okay, let's break this down for a second here. So if G prime is greater than 0, that means that G prime is positive. That means that G of x is increasing. Okay, So let's remember, G prime is in charge of the slope. So if G prime is positive, I have a positive slope, my function is increasing. Now let's talk about this guy. If G double prime is less than 0, that means G double prime of X is negative. That means that my graph is concave down. So it's increasing, but it's concave down, then it's going like this, right? It's increasing, it has a positive slope, but it's concave down. So overall, my graph should be getting flatter. That means that my jumps should be getting smaller. So if I jump from 12 to 18, that's plus 6, then my next jump needs to be smaller than 6. So first of all, let's just eliminate some options here, right? If I tried to put 15 in this spot, 12 to 18 to 15, then I'm not even increasing anymore. So I can cross out A, I can cross out B. Okay, if I picked B, 18, I'm not increasing either because I would just be staying the same. If I go to 21, let's just pretend for a second. Okay, 21, then my graph goes from a jump of 6 to a jump of 3. Is that getting flatter? Yes, it is. What about if I went to 24? So this seems good. Let's check 24 though. If this is a 24, I would have jumped 6 again. Is that really getting steeper or flatter? No, that's the exact same size jump. That means that I'm going up the exact same amount of time over and over. I'm not getting steeper or flatter, so that can't be right. And then if I go to 27, I would have jumped 9 units, which is bigger than 6, which would have been steeper. Okay, so it has to be C. So remember, you want to think about first, am I increasing or decreasing? Eliminate some options. And then remember, if your signs for F prime and F double prime match, your graph is going to be getting steeper. If they're opposites, your graph is going to be slowing down or getting flatter like we had here, because the first derivative was positive, but the second derivative was negative. Okay, all right, great job, guys. Keep working. You can do it, and I will see you guys tomorrow.